Okay, so this is our first example for linear programming. Basically what this involves is all of the sections that we've done up to this. We are creating a system of linear equations based on the description, and we're going to answer a few questions in the actual problem. We're going to use our graph, and some of the values that we're going to see in the graph will give us our answer. And so this worksheet, you should have printed it out to go along with the video if you wanted to. If not, you can just take notes. And so we'll talk about the problem here. So Jane is planning to start a home-based business. She will be baking decorated cakes and specialty pies. She estimates that a decorated cake will take 1 hour to prepare, and a specialty pie will take 30 minutes to prepare. She plans to work no more than 40 hours per week and does not want to make more than 60 pies in any 1 week. If she plans to charge $34 for a cake and $16 for a pie, find a combination of these two things that's going to maximize her income. So she wants to have an informed business plan that says, in order for me to make the most money, I need to sell this many cakes and this many pies. And so we're going to help her determine what's the best combination for her business. And so the first thing that you can see here is we need to define our variables. And generally speaking, what I like to do, and we should just keep it consistent, is the first thing that it talks about, call that your X, and then the second thing that it talks about, the second object, so the cake and the pie, those are two different objects, so we're going to call cake X and pies Y, and you can see that right here in the notes. And now we're going to write a system of inequalities to represent the constraints. The constraints are the limitations of her business. Okay? Decorated cakes will take 1 hour to prepare, and specialty pies will take 30 minutes to prepare. She plans to work no more than 40 hours per week. Okay? So that's relative to time. So time is going to equal a constraint. Okay? So we're going to use that as one of our constraints. Another constraint is does not want to make more than 60 pies in any 1 week. Okay? So number of pies is another constraint. She wants to work no more than 40 hours. So that's going to be our time constraint. We have our pies constraint. And it looks like, as I read through this, we have everything that we need regarding the limitations of the business. Now, this very last sentence right here where it talks about charging, that's what's called an objective function or objective statement. She wants to make money. That's not a constraint. The constraints are the limitations on the business. So when you read through these problems, you have to also identify what the objective function is, and that's going to be later on in step 5. So let's go ahead and try and create a linear equation, inequality, based on our constraints. Two things that pretty much are always going to be existent with these application problems, only when it's an application problem, we can't have negative cakes or negative pies. So we're always going to be greater than or equal to 0 for both our x's and our y's. Okay, so now let's look at the first one. A decorated cake is going to take 1 hour to prepare, and a specialty pie will take 30 minutes to prepare. So the time that it takes to make these, okay, so 1 hour for a cake plus 30 minutes, which is a half hour, be careful with our units, has to be less than or equal to 40 hours. She doesn't want to work more than 40 hours in a week. Okay? Now, she also does not want to make more than 60 pies. So 60 pies is going to be less than or equal to 60. And so right here we've set up all of our constraints, and now what I'm going to do in the third step is I'm going to graph it. So the first step, identify the variables. The second step, write a system of inequalities based on what we see in the problem. And the third step is to graph the system. So the first guys I'm going to graph, and I'll number these. I'm going to graph the easy ones. So x is greater than 0, so I'm going to graph a vertical line, and they're solid because they're equal. She can not make anything, so 0 is fine. Y is greater than or equal to 0. So I know that I'm going to shade in this first quadrant. Okay? So that's my first thing I notice is it's going to be graphed somewhere in this first quadrant. I'm going to create a scale, but before I do that, with this third one, I see the y is less than 60, so I don't want to start with 1s, 2s, 3s, and 4s and stuff like that. I'm going to take this third one because that's one of the ones that is kind of difficult to graph based on the numbers. It's not easy. We've got to manipulate it a little bit. So what I like to do is I like to find the X-intercept and the Y-intercept because this is actually the best way to work these types of graphs. These points are actually going to be used in the later steps in the problem. So to find an X-intercept, I know y is equal to 0. So it means if y is equal to 0, I'm going to set it equal to, because I'm just finding an intercept. I know the X-intercept is 40. At a Y-intercept, I know X is equal to 0. So I'm just going to solve for Y, and so Y is equal to 80. So if I plot the point 40, 0, and I plot the point 0, 80, I can just graph the line between these 2 points. Okay, so now I'm going to go ahead and I'm going to create my scale. And I'm going to go by 20s because I see the 60, I see the 40, and the 80. So 20, 40, 60, 80, we'll go to 100. 20, 40, 60, 80, 100. Okay? And the scale for each of the graphs is going to be different, so it depends on the problem. So we already graphed 1 and 2. So this is graph 1. This is graph 2 right here. Graph 3, I'm going to plot 40, 0, so 20, 40. And then I'm going to plot the y-intercept, which is 0, 80, and I'm going to go ahead and graph that line. Connect the dots. Okay. So I need to be less than. So I'm looking at my inequality less than. And I also pay attention to what's in front of the y, because if this was a negative value, we're supposed to flip our inequality. Because y is positive, it's still going to stay less than, so I know I'm going to eventually shade in this region. Okay? And now the last one I have is y is less than or equal to 60. So I'm going to go up to the 60 value. I'm going to plot the point there. And I'm going to draw my line. This is where I'm going to shade. And with linear programming, based on what's being asked of us, it is known that the solutions to what this problem Jane is having is going to exist on one of these vertices. So these are called corner points. These corner points are what we're going to use to tell Jane the best combination that she can have for her business. Okay, so now we're going to find the coordinates. Because I used this idea of plotting x and y intercepts, 3 of these points are easy to find. We have the origin, which is 0, 0. We have this point right here, which is our x-intercept, which is 40, 0. We have this point right here, which is our y-intercept, which is 0, 60. And then I have this point right here. Well, it crosses a horizontal line at 60. So I don't know what the x value is, but I know the y value is 60. So if we look under step 4, I'm going to start doing my work here. I'm going to move this sheet of paper up a little bit so we can start seeing more area. I know that the line that crosses it is 1x plus 1/2 y is equal to 40. I ignore the inequality when I'm just trying to find what the x value is. So I plug in 60 for y, and I solve. That's going to be 30, so x is going to equal 10 at this point. Do not use the graph to approximate. We want the exact value by plugging it in. So now I have my 4 vertices that I can plug into my objective function and determine the maximum value or the best combination for her. So we want to write an objective function. The objective function was based on how much she was going to make for cakes and pies. So her profit is going to equal 34x for cakes plus 16y for pie. And notice when we read the objective function, everything else had a constraint. She plans to work no more than 40 hours. She wants to work no more than 60 pies. One of the keys to find the objective function is to look at it and say, she plans to charge 34 bucks for a cake, 16 bucks for a pie. There's nothing in here that says she wants to make no more than $300. That's your clue to find out that that may be your objective function. And so that's our objective function. And so what we have here is now we're going to take all our vertices. So I'm just going to list them in this table that's here for you. And I'm going to write my objective function here. And I'm going to plug in the values. So hopefully this one's a quick one. She sells nothing. It's no profit. And then I take my trusty old calculator out. 34 times 40 gives me a profit of $13.60. Not a bad weekly payday for cakes and pies, huh? 34 times 0 plus 16 times 60. So calculate 60 times 16. That's $960. And then 34 times 10 plus 16 times 60. So that gives us $1,300. So the maximum profit is $1,360, and that was obtained by selling 40 cakes. Her minimum profit is 0, and that's if obviously she doesn't make anything or doesn't sell anything. So it's in her benefit to just sell 40 cakes based on how much she's charging and the time constraints that she has. And this is the step-by-step process you would go through. This is the step-by-step process that you would go through in order to solve one of these linear programming problems.